So here in Cisco Packet Tracer, we are going to build this bus topology as seen over here. What I have done is I have taken 4 switches. You can choose the switch from these tools which are available in the Cisco Packet Tracer. I have taken 4 switches like this, 295024 switches. Each of this switch has got 24 ports. Usually the switches have 24 ports or 48 ports. After taking these switches, I have taken the automatic connection to connect these switches. So let's connect the switches like this and take 4 computers like this and connect each computer to the switch. Connect each of the computer to a separate switch. So in this way the bus topology is formed using Cisco Packet Tracer. In Cisco Packet Tracer we do not have provision to use the common backbone cable as the coaxial cable and make the T connections with the coaxial cable in order to form the bus topology. So we take the switches and form the bus topology in this manner. Now I have assigned IP address on each of these computers here as seen over here. I have taken this note to write the IP addresses. You can write the IP addresses like this. IP address, let's say the IP address for this computer is 10.0.0.10 and gateway IP address is 10.0.0.20. Now already I have constructed this bus topology over here, you can see. So I will delete this other bus topology and explain you the bus topology with the constructed one. Now how to assign the IP address on the computer? You can click on each computer, enter its config tab. Here you can see the fast Ethernet interface of the computer. Here you can configure the IP address. IP address of this computer is 10.0.0.10 and subnet mask is 255.0.0.0. The gateway IP address cannot be assigned from here. The IP address can be assigned from these settings. Gateway is 10.0.0.20. Other option to configure the IP address is to click on the desktop and choose the IP configuration. Here you can configure all the IP addresses, IP address of the machine, IP subnet mask and the default gateway. The subnet mask is 255.0.0.0 because the IP address which we have used here is 10.0.0.10 and the first octet value of this IP address is 10, which is lying between 0 and 127. So this IP address belongs to class A. For class A, the default subnet mask is 1 octet high and remaining 3 octets low. Now similarly, I have configured the IP addresses on the remaining machines. The IP address on the second machine is 10.0.0.3. The subnet mask is 255.0.0.0 and the default gateway is 10.0.0.20. For each of the computer connected in this bus configuration, the default gateway will be same because the traffic will be routed through the same gateway. As the network is same, they are forming a local area network. The devices are forming a local area network here. So gateway should be the same IP address for all of these devices. Similarly, I have configured the IP address on the third computer. You can see here the IP address on the third computer is 10.0.0.4 and its subnet mask is 255.0.0.0 and default gateway is 10.0.0.20. Similarly, I have configured the IP address on the fourth computer. You can see over here the IP address configuration for the fourth computer. 10.0.0.5 is IP address, subnet mask is 255.0.0.0. The default gateway is 10.0.0.20. Now IP address assignment is complete over here. Now let us check the ping response from one computer to another computer. You can test the connectivity between any pair of devices here because these devices are connected via this common bus cable. Now I will click on the first computer and click on the command prompt of the first computer, and then I'll use the ping command, which is a tool to test the connectivity in the network. Now, which address we should ping? We should ping the IP address of this fourth computer, which is 10.0.0.5. So let us ping that IP address, ping 10.0.0.5, ping 10.0.0.5, and to this ping command we should get successful response. We have received the successful response from the fourth computer. It means that the first computer can talk to the fourth computer via this bus configuration. Similarly, you can test the connectivity between these two devices, second computer and the third computer, and so on and so forth. So the communication is successful with the help of this bus topology. Now, after doing this, you can observe the packet flow sequences by taking a PDU. Simple PDU can be chosen from here, and you can decide the source and destination for this packet data unit. Let us say the source is this first computer and the destination is the last computer. After doing this, you have to select the simulation tab and run the simulation. As soon as you run the simulation, you have to observe the packet flow sequences. You have to observe from where the packet is moving to which place. Now once I hit the run button, the packet has moved from PC1 first computer to switch, from this switch to second switch, from second switch to say the third switch, and from third switch to the fourth switch, and from fourth switch to the last computer, because the last computer was the destination. So here the last computer has received the packet and it has generated the acknowledgement. Acknowledgement is now forwarded to switch. That switch forwards acknowledgement to next switch. The next switch forwards acknowledgement to the other switch, and this switch will forward the acknowledgement to the first switch, and after that the acknowledgement will be forwarded to the source computer. So in this way the successful communication is established with the help of this bus configuration. Now let us see the dynamics in this bus configuration. Let us observe what will happen if we break a link between the two devices, or there is a break in the common bus connection. So I'll delete these packets first. From here I am deleting the packets, and now I am going to create a cut in between these two devices, so I can remove the cable connected between these devices with the help of this option available in Cisco packet tracer. I am deleting this portion of the cable, and now let's test for the ping response between first and the last computer. So for that I'll use the ping command again on the first computer. Ping the same IP address of the fourth machine. This time we should not get the successful response because the common bus cable is broken. So we are able to see here pinging 10.0.0.5, but there is no successful response because the common bus cable is broken in this portion. So this is the drawback of bus configuration, that if the common bus structure fails, the communication is not possible. Now let's move on to the another topology. For that I have to open the topology which I have already saved. So I'll open the mesh topology now. I have already created this mesh configuration. Now let me explain you how I have created this mesh topology. I have taken 24 port switches over here, 5 24 port switches I have selected, and I have connected each of these 24 port switches with all other switches and I have connected a computer to each computer over here. Now after constructing this topology, I have assigned IP address on each of the computer over here. The IP address on this computer is not yet assigned, so let us assign that IP address. The IP address on the computer that is PC12 over here is, let's say, 172.16.0.4. Now this IP address has got the first octet value as 172, which lies in the range of class B IP address, because class B IP address is in the range from 128 to 191, and 172 value lies in the range of class B IP address. So for class B IP address, the default mask is 2 octets high and remaining 2 octets low. So the subnet mask should be 255.0.0.255.0.0, and the default gateway, let's say the default gateway is 172.16.0.25. Now this IP address is configured on this machine. Now let's configure an IP address on this PC10. I have shown here the IP address for PC10 as 172.16.0.2. So let's configure that IP address here, 172.16.0.2. Its subnet mask will be 2 octet high and 2 octets low, because it is again a class B IP address, and let's keep the default gateway as 172.16.0.25. All of the computers connected over here should have the same default gateway. They are connected in mesh and they are forming a local area network, so they should have a common gateway IP address. Now after configuring these IP addresses, you can repeat the IP address configuration on the remaining computers and test the connectivity between them. So since I have configured the IP address on this PC12 and PC10, I can check the connectivity between these two computers by using the ping command. On PC number 12, I am using the ping command for PC10, and PC10 is having the IP address 172.16.0.2. So I'll be typing here the ping command with 172.16.0.2. I should get the successful ping response. Okay, so this computer PC12 is able to communicate successfully with computer PC10. If I try to ping the IP address of this computer over here, that is PC9, then the IP address is 172.16.0.1. I should not get the successful ping response because I have not yet configured the IP address on PC9. So I am not getting the successful ping response here. Now in mesh topology, even if a link is broken, let's say the link between these two devices is broken, then also the topology can work, because there are alternative paths from PC12 to PC10 and communication can take place through the alternative paths, and here there is peer-to-peer communication between any two nodes. Now let's take a simple PDU and define the source and destination for that simple PDU. Let's say the source is PC12 and the destination is PC10, and let's see the response. The connection is successful over here. You can observe in the right side down corner that the connection is successfully established between PC12 and PC10. Now to observe the packet flow sequences, let us run the simulation button. So packet is moving from PC12 to switch 4, and from switch 4 it is moving to switch 5, and from switch 5 it is moving to switch 3, and from switch 3 it is moving to PC10. Now PC10 has received the packet successfully and it generates an acknowledgement. The acknowledgement is received by switch 3, then by switch 5, then by switch 4, and finally the acknowledgement is received at the source computer, that is PC 12. So in this way the successful configuration of the mesh topology is done. Now let us move on to another topology. For that I'll open the saved topology. Let's see the star topology now. For star topology, I have taken a switch and I have connected 4 computers to this common switch. So in this star topology, you can see there is a central controller to which number of devices are connected. The information from all these devices will be collected by the central computer. So there will be no privacy in this star configuration. And as seen here, you can observe the IP addresses configured on each of these computers. So let me check whether I have really configured the IP addresses over here. I have placed a note for the IP addresses there. Let's check whether I have configured the IP address on each PC. Yes, the IP address is configured on PC0 as 10.0.0.10. Its subnet mask is 255.0.0.0 and its default gateway is 10.0.0.20. Similarly, I have configured the IP address on the second computer over here. The IP address configured on this is 10.0.0.3 and the subnet mask is 255.0.0.0 for class A IP address and the default gateway is 10.0.0.20. Similarly, on the last computer, the IP address is configured as 10.0.0.5. The subnet mask for class A by default is 255.0.0.0 and the default gateway is 10.0.0.20. Now, after configuring the IP addresses, you can check the connectivity between any two computers by pinging the IP address. Now, let's ping the IP address of PC0 from PC5. So I'll click on PC5 and choose the command prompt and I'll use the command ping and the IP address of PC0, that is 10.0.0.10. I should get the successful ping response. Yes. So the devices are communicating here using the star topology. And now let's say this particular link between switch 5 and PC5 is broken, then device 5 will not be able to communicate with other devices. You can observe that fact. Let's say, let us break that link here. Let us break this link. If this link is broken, then PC5 should not be able to communicate with PC0. Let's try to ping again the IP address of PC0. Now you will not get the successful ping response because the link is broken. So if you try to connect again the link, the communication will be possible, and if this common switch stops functioning, then the entire topology will fail. None of the devices will be able to communicate because the star is not available, because the switch is not available in the network or it is not functioning. Then here let's connect a PDU to PC0 and PC4 and observe the packet flow sequences. So as soon as I define the source and destination for the packet data unit as the PC0 and PC4 respectively, source is PC0 and destination is PC4, I can see the successful connection here between PC0 and PC4 in the right hand down corner. Now let us observe the animation for the packet flow. I'll hit the run button over here. The packet from PC0 is forwarded to switch first, and from switch the packet is broadcast to remaining all computers in the network. So here the information is gathered by all the computers. So no privacy is maintained in this star configuration. Now as PC4 has received the packet successfully, it has generated the acknowledgement, and that acknowledgement is sent via the common switch to the source computer. So the packets are sent as well as the acknowledgements are sent via the common controller only in case of the star topology. So no privacy is maintained in the star topology, and if the central switch fails, then the star topology stops functioning. This is the drawback of star topology, but configuration is easy in case of star topology. Now let's move on to another topology. Let me open other topology which I have already created in Cisco Packet Tracer. Let's observe the ring topology now. This is a simple ring structure. To configure this ring topology, I have taken 6 different switches, 24 port switches. I have connected the switches with the help of this automatic connection. Then I have taken 6 different computers and I have connected each of the computer to each of these switch over here as seen in the topology. Then I have configured the IP address on each of the computer as shown over here. Let's check the IP address on this PC0. The IP address configured on PC0 is 10.0.0.10, which is class A IP address. For class A IP address, the default subnet mask should be 255.0.0.0 and the default gateway should be 10. It should not be, you can take other default gateway also, you can take 10.0.0.100 also, doesn't matter, but the default gateway should be common for all the computers over here because they are connected together in a local area network. So default gateway should be same IP address for all of the computers connected in this ring topology here. The default gateway which I have kept is 10.0.0.20. For each of the computer the default gateway is same but the IP address is different. Now let's say the IP address on PC5 is 10.0.0.5 and default gateway is 10.0.0.20. Its default mask is 255.0.0.0. So our IP addresses are already configured here. Now let's test the connectivity between PC0 and PC5. So I'll ping the IP address of PC0 from PC5 using the command prompt of that PC5. So ping the IP address of PC0, that is 10.0.0.10. The response should be successful, right? So PC0 and PC5 are able to communicate successfully here. Now what will happen if I break a link between switch 1 and switch 2 over here? I am breaking the link between switch 1 and switch 2 over here, and again I'll try to check the ping response from PC0 for PC0 from PC5. The ping response is not successful yet. Ping response is not yet successful. We are getting the request timed out. So what is happening here? If we break the ring structure, then the communication fails. So for that purpose we need to configure a dual ring structure so that if one ring structure is failing, the other ring structure can take up and the communication is possible. Now if I bring back the link between these two switches, then again the communication should be successful. Let's check it again. So on this PC5 I run this ping command again, the same ping command. I should get the successful ping response now because the link is up, the ring structure is again brought back, the link is again connected, but it will take time sometimes to give the successful ping response. Yes, now we got the successful ping response. Let's check it again. Yes, we got the successful ping response. Now let's check the operation of this ring topology with the help of a simple packet data unit. Let's connect a simple packet data unit. Let's define the source as PC0 and destination as PC5, and let's observe this successful response, successful connection between PC0 and PC5 in the right hand side down corner of this window. And let's observe the animation with the help of this simulation tab. I am clicking on the run button now. You have to observe the flow of packet right from PC0 to PC5. So on PC0 the packet is forwarded to switch 5. From switch 5 it is forwarded to switch 0 and switch 4. Switch will broadcast the packets to switch 4 and switch 5, and each of these switch will broadcast the packets to its connected devices. Initially, because the switch has not learned the MAC table. Now the switch 2 has forwarded the packet to PC5. PC5 has successfully received it, and PC5 has generated an acknowledgement for the received packet. The acknowledgement is forwarded to switch 2. Switch 2 will forward it to switch 1. Switch 1 will forward it to switch 0, and switch 0 will forward it to switch 5, and switch 5 will forward that acknowledgement to PC 0. So in this way, the communication takes place with the help of a common ring structure. Now let us study the other topology. For that, I'll open the topology which I have already saved. So far we have covered the bus topology, ring topology, star topology, mesh topology is also covered. Now dual ring topology. Now in this dual ring topology, you can observe that there are dual ring structures. So the purpose of this dual ring is to solve the problem of the single ring topology. In single ring topology, if the backbone ring fails, then the communication is not possible. But here we'll observe that with the help of dual ring topology, even if one ring topology is failing, the other topology can be used for setting the successful communication. Now let's check whether the IP addresses are configured on these computers or not. But before that, let me explain you how to create this ring topology, dual ring topology. I have taken 6 different switches over here. I have connected each of the switch to a computer, and each of the switch is also connected to other switches with the help of 2 different connections. Each of the switch is 24 port switch here. So each of the switch is utilizing 3 ports out of the 24 ports. 1 port is utilized to connect the computer, and the other 2 ports are used to connect with the other switches. For example, this switch 5 is connected to computer 0. It is also connected with the help of 2 connections with switch 0, and it is also connected with the help of 2 connections with switch 4. So altogether 5 ports of switch 5 are utilized over here. 5 ports of switch 0 are also utilized here. 5 ports of switch 1 are also utilized here. Each of the switch is utilizing 5 ports here. You can observe. So you can observe from this MAC table of the switch that the 5 interfaces are up in this MAC table. Each of the switch over here is getting connected to a computer and the other 2 switches. So total 5 connections are there with every switch here. Now let us check the IP address configuration on each of the computer over here. The IP address on PC0 is configured as 10.0.0.10. Subnet mask is by default 255.0.0.0 for class A, and the default gateway IP address is 10.0.0.20. Now similarly, let us check the IP address on PC5. The IP address on PC5 is 10.0.0.5. The subnet mask is 255.0.0.0, and the default gateway is 10.0.0.20. I have configured the IP address on each of the computer over here. You can see when I drag the mouse on this PC2, I can see the IP address on PC2 as 10.0.0.2 and its gateway is 10.0.0.20. Similarly, the IP address is configured on PC1 as 10.0.0.1. On PC3, the IP address is configured as 10.0.0.3. On PC4, the IP address is configured as 10.0.0.4. Okay. Now, let us try to ping the IP address of PC2 from PC0. Let's try to check the connectivity between PC0 and PC2. For that, I'll have to go on the command prompt and I'll have to use the ping command. Ping with the IP address of PC2. But what is the IP address of PC2? Let us check it again. IP address of PC2 is 10.0.0.2. So let me use that IP address here. Ping 10.0.0.2. I should get a successful ping response. Yes, I am getting a successful ping response. Now what I'll do is I will break the ring structure between this switch 0 and switch 1. One ring structure I am breaking over here. And now let's check the connectivity again. the connectivity will be possible via the second ring structure. I am using the same ping command, ping 10.0.0.2. So I am getting a successful ping response. So what is seen over here, that if the ring structure fails, primary ring structure fails, the secondary ring structure can take over and it can be used to have the successful communication. Fine. Now let us see the tree topology. For that I'll open the already created topology. See here what I have done, I have taken number of switches over here and I have connected one computer to every switch, and this structure is altogether forming an open structure in the form of a tree. The topmost tree is the root node here. The root node is having two child nodes which are nothing but the switches over here, and these two switches in turn are having their child nodes, and these child nodes are having again their child nodes. The bottommost layer forms the leaf nodes and the topmost node is the root node here. The open loop structure is formed here, which is open structure, tree structure, and I have assigned I have shown the IP addresses which can be configured on each of the PC over here. I have taken the class C IP address to configure on each of the PC, and the common gateway is 192.168.3.10. Now let me check whether I have configured the IP address on this PC7. On PC7, I have configured the IP address 192.168.3.7 and the default gateway is 192.168.3.10 and the subnet mask is 255.255.255.0. This is the default subnet mask for class C IP address. The IP address 192.168.3.7 is a class C IP address because the first octet value is 192, which lies in the range from 192 to 223. So it is a class C IP address. 191 to 223 is a class C IP address range. So this first octet value here is 192. So it belongs to class C IP address. And for class C, the default subnet mask is 3 octets high and the 4th octet low. Now similarly, I will check the IP address on this PC10 whether I have configured the IP address. Yes, I have configured the IP address as 192.168.3.10. It is again a class C IP address. For class C IP address, the default mask is 255.255.255.0 and the default gateway which I have decided is 192.168.3.10. Now let's check the connectivity between this PC7 and this PC10. So I'll click on PC10 and use the command prompt on PC10 and try to ping the IP address of PC7, which is 192.168.3.7. So here I can observe the successful ping response. So the devices can communicate with the help of this tree topology. Now let's take a simple PDU and define the source and destination for that simple PDU. The source is PC7 and destination is PC10. The successful connection is established between PC7 and PC10 as seen in the downside right corner. And now let's test the flow of sequences, packet flow sequences with the help of animation. I am hitting the run button here from the simulation tab. You have to observe the packet flow sequence. From PC7, the packet is flowing toward packet is received to switch 7, from switch 7 to switch 8, from switch 8 to switch 1, from switch 1 to switch 0, from switch 0 to say switch 2, from switch 2 to switch 6, and from switch 6 to switch 10, and from switch 10 to PC10. So what has happened here? The packet is traveling through the root node in the tree structure, and PC10 has received the packet successfully, so it has generated an acknowledgement. The acknowledgement will pass through the switches now, intermediate switches, and it will pass through the root node, that is switch 10 or switch 0, not 10. So the packet is received by the root node now, and root node will forward that acknowledgement packet to switch 1. Switch 1 is forwarding it to switch 8, and switch 8 is finally forwarding it to switch 7, and switch 7 will finally forward it to the source computer, that is PC7. So in this way the communication is established successfully with the help of the tree topology. So if the root node is not working here, the tree structure will fail. This is the drawback of this tree topology. Now let's see the hybrid topology. For that I'll open the already created hybrid topology. See, I have created the ring topology with the help of these 24 port switches. Now let's connect different topologies to this ring topology. Let's connect these devices to each of the switches over here. Now PC0, PC1 and PC2 are forming the bus topology. PC0, PC1 and PC2 along with the backbone switches is forming the bus topology. Now let's connect some of the devices in the mesh topology here. So I am connecting each of the switch to every other switch here. They are connected in mesh. Every node is connected to every other node in the mesh topology. And let's connect one computer at least with every switch connected in mesh, like this. So this is forming the mesh topology over here. This is the mesh topology. Now let us form the tree topology by connecting the switches and the computers. Every switch has to be connected to a computer. Like this. So this structure is forming a tree structure. So in this topology you can see the ring topology. The central topology is the ring topology over here. The devices are connected in the form of a ring. Then you can observe the bus topology, you can observe the mesh topology, you can observe the tree topology, and let's construct the star topology also. So let's take 4 devices here and let's connect these 4 computers to the common switch. With the help of this automatic cable connection. Now when you want to connect a PC to a switch, you need a copper straight through cable. So in this way this star topology is also formed. So here you can observe that there is combination of more than one topology in the single network, and such topology is called as the hybrid topology. So this topology altogether is a hybrid topology. Now you can assign the IP addresses on each of the computers here and define the common gateway IP address, and then you can test the connectivity between the devices. Let's configure an IP address on, let's say, PC1 On PC1, let's say the IP address is 10.0.0.1. The default mask will be 1 octet high and remaining 3 octets low for classy IP address. And let's define the gateway as 10.0.0.200. Now similarly, we'll configure IP address on say PC9. On PC9, I'll assign the IP address 10.0.0.9. Default mask will be 1 octet high and remaining 3 octets low for classy IP address. The default gateway should be same, that is 10.0.0.200. Now after assigning these IP addresses on these two computers, let us check the connectivity between these two computers. I am clicking on PC9 and I'll try to use the ping command for PC1. Ping IP address of PC1, that is 10.0.0.1. So I am getting a successful ping response here from PC9 to PC1. Successful ping response is achieved from PC9 for the pinged machine PC1. So this shows that PC1 and PC9 can communicate successfully. So here you can observe the successful communication between any pair of nodes if you configure the IP addresses on each of the nodes. And now you can define the source and destination for this simple PDU. Let's say the source is PC1 and the destination is PC9. In the right and downside corner, you can see the successful connection is established between PC1 and PC9. And to observe the animation, you can use the simulation button and check out the flow of packets, packet flow sequences. PC1 has forwarded the packet to switch 12, switch 12 has forwarded to switch 13, switch 13 has forwarded to switch 0, switch 0 will forward it to switch 1. So it is following a common ring structure now. The packet is following the ring topology first, from switch 1 to switch 2, from switch 2 to switch 3, from switch 3 to switch 4, from switch 4 to switch 5, from switch 5 to switch 6. The packet is now moving from switch 6 to switch 18, and from switch 18 it will move to switch 20, and from switch 20 to from switch 20 to PC9. So in this way, the successful packet communication is observed from PC1 to PC9 in this hybrid topology. Thanks for watching.